So this is Marcio Almeida and Justin Stephen. Their talk is Sleepless Strings, Template Injection in Insomnia. So big round of applause.
Thank you.
Thank you, everyone. My name's Justin. I'm the head of research at Tanto Security, and I'm joined by Marcio, one of our co-founders and our technical director. We've got a story that we're really excited to share with you today. We call it Sleepless Strings, and it's a story of a template injection vulnerability in a client-side application. And before we get into it, a little bit of housekeeping. We want to talk you through the lineage of our communication with the vendor on this one. And as an illustrative tool, we're going to be using these little chat bubbles. These aren't copy-pastes of the email conversation we had. These are just an illustrative tool to kind of show you the timeline and the cadence of the journey we went through with the vendor to see these bugs be patched, or maybe not be patched. Before we get going, we'd like to level set. What are templates, and how do we at Insomnia Security, not Insomnia Security, Tanto Security, think about templates? So a template is like a document with placeholders in it. You can think of these as gaps. Different templating engines have different syntaxes. Some of them use these little curly braces, but these are like little holes where data can go. So a developer can write a template once and then slot data into it multiple times. This template is fed into a templating engine, and alongside it are some parameters. And these are those values to fill in those gaps. You turn the handle on the engine, and out pops a rendered document with those little placeholders filled with the values. These are often used in web technologies. A developer will write a HTML document with these little placeholders or these little gaps in it, and then reuse it multiple times for different users to fill in some dynamic data. And what's neat about template rendering is it's a way for data to be safely interpolated into a document. It's intended for attacker-controlled data or untrustworthy data to go into this parameters side. In fact, a lot of templating engines will automatically HTML encode stuff for you. So it's a good way to get XSS protection if you're building HTML documents from dynamic data. This automatic HTML encoding can be turned off if you're not using it to build HTML. It's a handy feature to have. And for the rest of this talk, we're going to put HTML to the side because the app we're talking about isn't building HTML. So you can forget I said this or forget we said this, but this is a bit of background as to how templates are often used. But what's important is that it's generally considered safe to feed untrustworthy data into the parameters side only. Untrustworthy data going into the template side can have interesting consequences. This was really brought to prominence in 2015 by James Kettle from Portswigger. I think it had been discussed prior to that, but James really brought it into the limelight with a bug class called SSTI, or server-side template injection. Because when an attacker can control and bring some squiggly boys to the party, some more interesting things can happen. These template engines are quite powerful technologies. Here's a little collage we've built of various different syntaxes for various different templating engines to show you the complexity and the power and the grunt behind some of these engines and what the squigglies can do. Not all templating engines are made equal. A lot of them are really, really powerful, and these squiggly braces, or whatever the syntax is, can do some interesting things. Some of them aren't so sophisticated and may be considered safe to allow an attacker to control the template. But as a general rule, it can be considered unsafe for an attacker to control the template. If they can, then weird and wonderful things may happen. And speaking of wonderful, I'd like to hand over to Marcio.
Thank you, Justin. All right, guys. Now, let's talk about the tool, actually, that brought us here today. Cool. So what's Insomnia? It's not like the problem that keeps us awake at night, but it's actually an API tool developed by Kong Incorporation. So the main goal of this tool is like users can create example requests, right? So developers can create that, and they have like all those requests that from his API instead of like or pretty much they just get like a Swagger file or open API documentation or WSDL and create example of the requests so they can quick test it, like sending the request to the API and grab the response, right? And it's developed in Electrum with, in this case here, they have like a Node.js integration enabled. And most of the tools actually that do the same thing, like the Postman, for instance, they also developed in Electron. And Insomnia is also a great alternative tool to the Postman itself. I think everyone else, most people is familiar with Postman because it's probably the most well-known tool that do the same thing. But like myself, I decided to change tools since they kind of like moved from, I don't know, let's say a business model where you could load local scratch pads. That's, in my opinion, a very important feature for us as pen testers, because when a client sends to us a collection file like that, probably is full of credentials, right? Sometimes it's just like the credentials for the development environment, but also in some occasions will be like when they ask us to test in a production environment, if they do not have configured, like for instance, an API to grab authentication material will be in those files. And in our perspective, at least in my perspective, like synchronizing this kind of information to a cloud environment that does not belong to the client, but belongs to you, yourself, and anything bad happens to your account and those credentials end up leaking, it'd be pretty bad. So the idea of having like a local scratchpad for me is primordial. And when I look up for tools, I end up like finding Insomnia, and I really like it, like straight away. Have most of the functionalities that I was using with Postman itself, and yeah, that was the main reason that I decided to use this tool. Cool. Now I'm gonna explain to you guys how I do my API pen testing workflow, right? How most of us attempt to do it. It's pretty much like a common, I guess, like everyone do the same way. So here I have like Insomnia, where we ask the client the API collection, right? So that's one of the files that we ask them when we talking with them, asking for information about APIs, besides all the documentation that they can give to us. We usually ask this collection file, because it's an easy way for us to grab this thing, load inside of our API client tool, and we can start like testing those parameters straight away. On top of that, I like to use Burp Suite as a proxy for that. Why? It's because Insomnia is great for having all those API things there, but if I want to fuzz a specific parameter for, I don't know, tests on my doors or for input validation vulnerabilities, Burp Suite can give me this power with Intruder, right? Or if I need to manipulate the headers of the request or something in the request in a better way, quicker way, Responder can do that for me as well. And not only that, for us to take the evidence, for instance, we like to have the request and response in the same screenshot so the client can see what's going on in the request. So yeah, that's the way I set up my environment. And of course, Burp Suite is going to be the client for the target API. Cool, now that we understood that, let's talk to you guys little history like how I stumbled in this vulnerability, right? So here's me one day doing a penetration test API to one of our clients, and like I remember I was testing this API, and they had one functionality that I took some parameters and it returned like some sort of like a built HTML in the JSON response of it. So I immediately thought, okay, maybe what I can test here. Cross-site scripting, of course, and also template injection, right? So of course, I went there and sent the most infamous payload for testing template injection. That's pretty much like a curly braces, 7 times 7. And that's a simple mathematical operation that should return 49 if it's like a resolved, right? In my mind, when I click send from Insomnia, it was sending that payload to Burp Suite. Burp Suite was passing that through the API and would return. And for my surprise, the response actually came 49. And easy win, celebration, nice. That's it. SSTI, now let's take some evidence and try to exploit further, right? However, when I tapped in to take my screenshot, I noticed something very odd. Actually, in the request, there, instead of having my payload that I put before, I actually had 49 directly there. And that was the reason that I actually received 49 as a response from the API. And then when I used Burp Suite directly to send my payload to the application was actually not vulnerable. It was returning my string as a payload. And then I'm like, okay, what's going on here? And then I tapped back to Insomnia, opened the request that I was manipulating, and as you guys can see here, the place where I put the payload, it became automatically rendered in the application, let's say GUI, as something that we call like an environment variable. So environment variables are used for multiple things, but the principal usability of that is to configure, for instance, credentials or anything that you use across multiple requests. Then when I click in the 7x7, then I understood that actually it was being parsed by some sort of like a template engine inside of Insomnia itself. And I found this a little bit odd because it was like just after I changed tools as well. And when I went in Postman, that does not happen. Like the curly braces things inside of Postman is just used to actually map a string to another string, and that's it. And here, it was actually evaluating the content. And that since it was environment variable, then I tapped back to the management environments. And here is where we configure, like, let's say, the credentials that we want to use across requests. And here I have like some examples of fake data. And I noticed something very interesting in this page. In the bottom here it says, environment data can be used for non-JUX templating in new requests. And I'm like, oh, non-JUX? No, actually, I'm not like a JavaScript developer. And it was the first time that I actually heard about this template engine, right? So, okay, this is even safe. Then I started researching about that. And when I went to the documentation of like a non-JUX, the first thing they have like a pre-read on top is like a user-defined templates warning. Non-JUX does not sandbox execution. It's not safe to run user-defined templates or inject user-defined content into a template definition. And funny enough, that's exactly what like Insomnia is doing as functionality, as default, right? And that was pretty sus. And however, like I told you guys, I was doing like a penetration testing, right? So I need to finish the job that I was doing. The more that I love finding this kind of like unexpected bugs in tools like even that I was using, and that's probably would deviate my attention and was completely out of scope, and I need to deliver this job. So I took notes of everything that I found so far, put in my research notebook, and that's it. So a few weeks later, my next research opportunity came back, and I was back exactly to the point where I stopped. Okay, non-JUX, after I started analyzing a little bit more, is a very powerful template engine that's pretty similar to Jinja 2. They actually have like a lot of similarities in functionality. Like one of the most powerful features in Jinja 2 is the ability of like manipulating strings using filters. And non-JUX has the same thing. And another thing they also have like in common is the access to the ability to potentially evaluate arbitrary JavaScript code. In the case Jinja, Python, in this case of non-JUX, JavaScript code. Cool. And when I just like did a quick Google on the internet, hey, there is like any potential payloads to get code execution using SSTI in non-JUX, and there is multiple ways. And this one is the simplest one that I found. And I don't know, like what Kong was thinking when they decided to implement that functionality, but if they just did the same thing, probably they find that massive red flag. However, they found that probably was fine. So I just copied this payload, copied to inside Insomnia to see if it would work, and first try, that it was. Get code execution as Marcio. So to better visualize, I just slightly modified this payload, added an alert. Then you can see the command execution pop up. Cool. Now I have the payload. I just need to convince someone, saying to them, hey, can you copy that inside of Insomnia clients? And that's it. Get code execution on the machine, right? But that will probably be obvious phishing. Not going to work. So I need to find a better way to do that. The obvious way would be to use the import collection that we ask to people. So I don't know, even imagine like North Korea find something like that's inside of the HTTPs, right? Convincing devs to download and execute things in their machines. Simply like you just need to generate one of the collection files, put your payload there, load that inside Insomnia, tab to the requests that have the payload, and get code execution. So how that would work in practice? Pretty much like this. So just go to Scratchpad, import, load your malicious file. It's gonna quick scan the contents. And that's it. Tab to the request, get code execution. Easy as. Nice. And then we got like a very cool proof of concept. And potential plausible pretext to convince someone to download our malicious file and execute it. However, the payload is still there in the file and can be spotted, right? But hopefully that will be enough. And I think it was time, I discussed it with Justin, and we thought, okay, time to report to them, see what they say. Cool. So the first thing that we do when we trying to report vulnerabilities to vendors, right? We're looking to directly in the GitHub, usually of the product that we trying to find, we're looking for vulnerabilities. And when we go to the security tab to report stuff through GitHub, usually they handle all the CV parts and everything, but Kong is a CNA by themselves and they don't like to receive reports this way. So the way they ask is to send email to them. And then we visit the web page and we were surprised, but actually they had like at the time when we reported this vulnerability to them, they had a self-managed bug bounty program, meaning that like they offer up to $1,000 USD in gift cards for critical bugs. And also Insomnia desktop clients were inside of the scoping of this bug bounty program. So as researchers, it's pretty nice, like a pretty cool bonus, right? On top of like when you find some vulnerability and want to report and you find someone actually offer bug bounty is a great indicative they are like a keen to work with researchers. And not only keen to work with them, but also remunerate them financially somehow for their efforts in reporting vulnerabilities to them. So it's pretty cool. Yeah, so remember, this chat bubbles here is just like a reenactment of like how was the conversation, not like a verbatim by verbatim, but then we sent the first message. Hi, we want to report a bug that leads to code execution when user imports a collection file. We are writing a report and we will send to you soon. And by the way, as well, we have like a public vulnerability disclosure policy, and we publish details once it's fixed. So our vulnerability policy is pretty much like similar what other companies do. Like Google, ours is heavily based on theirs. So once we like send the details of the vulnerability to the vendor, we give them like 9 days to come up with a viable patch to patch this vulnerability. And after that, after the patch is out, we also give 30 days to start talking publicly about that. So that's it. And we told them since the first message that was our plan. And they said, oh, thank you very much, but I already know about this vulnerability. And duplicated issues aren't covered by our bug bounty program. So yeah. I guess everyone that did like a bug bounties in life at least saw this message at least once in their life, right? So yeah. Cool. So they say they already knew about that. And then I talked with Justin and we did like a more thorough search inside of the GitHub. And turns out that actually someone had created a public issue and talked about this vulnerability. So I don't know if you guys can see here, the payload they use is slightly different than the ones that we used, but the result is the same, right? And they also mentioned the ability, the potential of this vulnerability to be used in the importing files. And when we messaged Kong, they actually said, oh, you can use this vulnerability as well, I don't know, loading by a cross-site scripting, or when you navigate to Insomnia : / that's the URL handle they use to import files. So there was multiple ways to do that. Okay, then I talked with Justin, and Justin said, okay, man, it would be awesome if we could like improve this exploit. Like, okay, let's try to do it. I didn't like the payload anyway because like it was there in the file and could be like easily spotted. So can you do better than this? My mindset to attempt to find that was, okay, we know that this app like handles template everywhere. So let's start mapping this. Just so you have an idea, it's a lot of places, mate. And the first one, just like HTTP request here, pretty much all the fields there are template handling. And manage environments as well, as I told you guys, and manage cookies too. And when I went to manage cookies, and I noticed that actually could create templates in there, and in my mind, I think they allowed to do that there, just because potentially it could like create some sort of templating where it would fetch dynamically some sort of cookie to plant there, and it will be automatically filled up every time that someone sends a request, right? But since like the functionality of cookies was templates and handling, then I thought, okay, maybe Insomnia is working as a browser as well, meaning that like if you receive a cookie in a set cookie header, it will also set the cookies inside of the application. So to test my theory, I quick wrote like a Python script that will do just a simple job of setting a cookie, and that's it. When I send the request to that app using Insomnia, tabbed back to manage cookies, there was the cookie. So it was actually working as a browser behavior, right? Next step was obvious. Okay, can I set like a remote template and that will also be added to the app? That was what I did. Put the same payload there with a slight modification, so you'll not have like any errors in the in the application interface. And when I sent the request, I got the pop-up. But here I was still navigating to the managed cookies, right? Another behavior that we noticed and was pretty interesting is because Insomnia, every time, so at this time, we were thinking, okay, do we need to every time navigate to manage cookies to get the code execution? And it turns out that we didn't. How it works pretty much is like it sets the cookie in the cookie jar, and every next request that you send, the application automatically loops in every cookie, try to evaluate them, and matches the domain of the request that you're trying to send. And if they match, they just add the cookie to the request and submit. So that meant that actually, instead of like a poison the cookie, navigate to manage the cookies, I just need to send 2 requests to using Insomnia. One to the malicious server, and the next one to anywhere. Okay, so let's see that working. So pretty much here we have like Insomnia, normal. We send the first request. If you guys notice in the top left here, manage cookies appears 1 there, means that the cookie jar was poisoned. In the next request, we get our code execution. It meant that like every request after that will be like exec, 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 exec. Cool. So we thought, nice, we could like simply put like a connect back shell there, but in case that we don't have like, let's say, or you have like a firewall and stuff, you can't leak the content. How about we used cookie itself to leak this information? So we wrote like a quick Python script that will execute our command, grab the result of our execution, put in the cookie, and in the next request, that information will be sent to the server. So it worked like pretty much like that. First request, poison. Second request, you get the results of the command that you put. And we can keep doing that like in loop, right? So why use a C2 when you can use the cookies itself? Nice. So I found a very cool exploit this time, where the file where we send to share to the user will be completely clean. The only thing that we have there is a URL to a potential malicious server. And not only that, since we control the server where the payload gonna go, we can increase the OPSEC, basically, let's say, matching content header of the user agent, right, to see if it's Insomnia, and if it is, we deliver our payload. If it's not, we completely ignore those requests, so we'll be on the clean. And from here, my friends, your imagination is the limit now. Pretty much you could even like write a whole C2 implant if you wanted using this idea. Nice. So it was time to tell Kong about our findings again. So we have been working on this. We can now exploit it over HTTP malicious request. And yeah, how do you want to receive the report? And they say, okay, please the details via email. And on top of that, we have reconsidered what we said before, and we want to treat your findings as a new finding, because it seems like you guys are into something new. And yeah, we're pretty keen to see your POC. And then we sent an email where we attached our POCs, described like how Insomnia could be exploitable via all multiple ways that we found, at least the ones that we found in the template handling. And we also say that we think that the cookie technique is pretty interesting because it can be completely remote, right? And yeah, now I'm gonna pass over to Justin, that's gonna discuss about the recommendations that we did, and a lot of fun. Good, Justin.
Thank you, Marcio. So we looked at what Marcio had found. And the cookie technique we thought was really interesting. As Marcio said, it turned this into a completely remote bug that didn't require a user to open a file or perform as significant user interaction. But at the heart of it, we thought it fit this pattern. We thought it was a case of untrustworthy data making it into that template side of a template rendering engine. And we're a big fan of Portswigger's advice on template injection. They've got a Web Security Academy article that has a discussion area about how developers can protect against template injection or resolve template injection issues. It's kind of this 4-step process. It's this 4-step grief handling process for template injection. And it's presented in the order, it seems to be presented in the order in which Portswigger is suggesting that these types of issues become remediated. First step is don't do it. Don't pass attacker-controlled data or untrustworthy data into the template side of a template engine. But they say sometimes you have to for functionality reasons. If you're going to do that, use one of those less sophisticated engines like Mustache. If you can't do that, it's getting pretty grim at this point. Maybe try and sandbox the template renderer. But they do call out that this can be, this is their words, inherently difficult and prone to bypasses. And the last step is accept that arbitrary code execution is basically inevitable, and then stick the template rendering stuff in Docker or something like that. We think this is pretty salient advice. So we pondered this and thought, what can Insomnia do about this issue? They can't do that first step. They can't stop rendering templates. It's a feature at this point that their users have come to depend upon. They probably can't switch out the template engine. It's going to break compatibility and change the syntax. So at this point, they're looking at probably stopping the bleeding. And we had two ideas for them. Maybe throw a warning when someone's importing a file saying this can be dangerous. We're all used to those now with things like Visual Studio Code. But importantly, we thought that one of the best things they could do would be to simply not render a cookie that comes from a remote server as though it's a template. So in our report, we expressed these thoughts to them. And then we followed it up by saying, as Portswigger says, trying to sandbox the templating or sanitize templates can be brittle and error-prone. They responded and said, we think this is a CVSS 9.3 issue. We're rating it as a critical bug, which is a huge change of heart from it being on an open GitHub issue for a few years and then saying we know about this issue. So it seems like this vector had kind of made them realize the true impact of this issue. They went on to say that we're going to prevent nunjucks from rendering require invocations, and they're going to work on isolation, which sounds similar to the two things that we said that we don't think are sustainable measures. At this time, the fix to ban or block or prevent the use of the word require was already in GitHub. They hadn't released it yet as a release, but the fix was there. The trouble being, at the point in the payload where the string require comes up that they're trying to ban, it's a string context, and there's umpteen bajillion ways to obfuscate or encode or otherwise mix around that word so it's not spotted by this kind of sanitization. I particularly like the one at the end, which is using nunjucks against itself to kind of flip the string around. And so we sent this off and said, look, like we said, we think sanitization can be brittle and error-prone. Here's a small handful of ways in which this approach can be bypassed. They came back and said, thanks, we appreciate that feedback. We still think this patch is worth it because it's going to break exploitation in the wild if there's any going on. And there was also telemetry in there as well. If this word require was spotted in a template, it was going to ship it home to Insomnia. Then they said, this is just temporary. We're still working on isolating the renderer within a web worker. So we kept an eye on Insomnia's changelogs. And then version 11 came out. And in the changelog, it said that they'd shipped this behavior in which the word require was going to be blocked. We got in touch with Insomnia. It said, look, we haven't tested this release yet, but we can see in the changelog that it's got a fix. We wanted to know if they were working on any additional fixes or hardening or mitigations at this time. Because now that a fix is shipped, our policy is that we will publish details to the public in 30 days so that everyone can be informed as to what's going on with this vulnerability. They got back to us and said, actually, we had to pull that fix from this release due to some stability issues, but we're working on integrating it into the next minor version. We said, okay, like we said, we didn't actually test it, we just saw the changelog. Just keep us posted and let us know what you're working on. We'd appreciate it. So we sat tight and we waited for that next minor version. 11.10 came out. We didn't see anything security relevant in the changelogs, but we fired it up and found out there was actually a few new protections in it. Basically, they were wrapping that require function and only allowing certain external JavaScript modules to be included from within the web worker. We didn't realize until we were preparing this. Our blog post says that this fix came out in 11.10. The reason why the changelog is blank on this is because this shipped in a prior release about a month earlier in a change called Show How to Run Send Request from Worker. We didn't realize that this was actually released earlier than we'd thought. But this is what that fix looks like. Created an allow list of certain modules that can be used with the require function from within the sandbox. And if you try and pull in child process so you can run an external process, you get yelled at because it's not on the trusted list. Turns out you can use module.require, which bypasses this wrapper, and you can still achieve arbitrary external command execution. So we let them know. We got in touch and said, hey, we saw 11.10, it looks like it's got some new protections in it. It can be bypassed using module.require. At this point, we'd hit the 90-day mark and a patch had been delivered. So we said, look, in line with our VDP, we're planning on publicly talking about this. We're going to publish a blog post in 30 days. They'd also said they were going to allocate a CVE, and we were curious if they were going to publish a notice as well so we could cross-link to it. And remember how they said they'd had that change of heart? We said, any updates on the bug bounty, have you come to a decision? And this was, mind you, we'd been very, very crisp and clear we're planning on publishing. And to our delight, they said, yeah, we'd love to give you an Amazon gift card. We just need to know which region you want it made out for. We told them we really appreciated this. We thought it was super, super appreciated. We haven't gotten that gift card. This chat went cold shortly after. They came back and said, all the payloads you've provided so far no longer work in 11.10. Which was strange because this email thread, we had just delivered a new bypass with module.require. And they said we're still continuing to work towards a long-term mitigation. So like we said, we started planning for our public disclosure of this issue. And while we were doing that, while we were writing our post, Insomnia 11.20 came out. Nothing in the changelog, but over on GitHub they said that they patched out the range global. But if you dig into that PR, it also patches out something called cycler. So what they'd done is they'd ripped out cycler and range from the nunjux environment. And our payload so far had been using range.constructor to kick off this chain of arbitrary code execution. So our payload had broken, and we were getting yelled at with an error message saying that range constructor is undefined or falsy. And it made us have to wonder, no, it didn't. That comes shortly. This rang a bell for us. Range and cycler rang a bell. Because remember this warning that Marcio talked about in the nunjux documentation? Elsewhere on that page, it talked about 3 global functions inside nunjux, range, cycler, and joiner. With 2 of them booted out, would the last one work? Yep. Joiner.constructor also did the job for us. So we published our blog post as we said we were planning to do. We discussed this bypass that we'd just found while writing that post. Got in touch with Insomnia and said, hey, look, we've just published a blog post, FYI. Also, joiner can be used instead of range. And this is the last we've heard from Insomnia at this point. So now we're into the post-blog post world. So if you've read our blog post, we hope you enjoyed it. But all of what we're going through now is fresh. We haven't talked about it anywhere else. In 11.30, there were 2 changes. Joiner was addressed, and tags in set cookie were also addressed, and we'll tackle these one by one. So as far as joiner goes, the third of our 3 stooges has been kicked out of the nunjux environment, and so we can't use range constructor, cycler constructor, or joiner constructor, which begged the question for us, what had that been achieving for us in that payload so far? Because we had a kind of vibe of what it was doing. It seemed to set up like a bit of an eval sync, so we could kick off arbitrary JavaScript, and then from there, pull in child process. So we need to find a replacement for that joiner constructor bit. And if we break down how this payload's been working so far, it starts off with joiner, which is a function in JavaScript. Everything in JavaScript is an object, and objects have things called constructors, and the constructor of a function is the function. It's the function building function. So we then call that with an arbitrary string, which produces the anonymous function, and we then call that function. So that's how that chain's been working so far. So we need to find a new way to get to the function using only the bag of tricks that gets put into the nunjux environment. Turns out there's heaps. Range, cycler, and joiner weren't actually that special to begin with. They were just range was what the published SSTI chains used. So if you tool around in a JavaScript console, you can go empty string.constructor is the string function, which is a function which has a constructor, which is the function, empty string to string constructor. There's a lot of ways to get to an eval sync from within nunjux. We just had been using the one that was public, which was the one that Insomnia had focused on breaking. So that handles the joiner concern. But what's going on with tags in set cookie? This was exciting for us. They had banned the rendering of cookies as templates, which is something that we had early on suggested as a way to stop the bleeding on this one.
Remote cookies. Remote cookies as templates.
Can't hear, sorry. Sad thing is they did it with sanitization. And here's how it worked. Given a cookie with curly braces in it, it was going to zap anything that looks like Nunjuck's template elements. So in this case, it would strip the curly braces off and just give you the string inside of them. The trap is that this replace chain happens one by one by one by one, which we can use against itself. So it's going to work left to right. Given this example sequence of characters here, we're going to look for left squiggly brace, left squiggly brace. We're not going to see any. Look for right squiggly brace, find it, zap it, and bring that outside together, and then look for the rest, not find them, and we're left with what we were looking for. We can kind of build this sandwich where the meat protects the bread, which comes together. This type of sanitization works if you repeat it until the water runs clean, but that only works if the string is shrinking. If it's changing or growing, you can end up being put in an infinite loop. So it was an admirable effort, but it was able to be used against itself to still smuggle in template sequences. We got bored trying to find the second way to do it for the right squiggly brace, so we just brute forced it with Python. Putting these two tricks together, the cookie chain still worked, we could still get to arbitrary code execution, and we're able to still pop shell and pop calc. But just this last weekend, as we were building slides, we had a thought and found another way to defeat that cookie sanitizer. And that is that Insomnia can be made to do what's called double interpolation. If rendering a template results in something that looks like it's still a template, it's going to run it again, which is its own concern. Re-rendering a rendered template can be problematic, even if an attacker only controls the parameters on the left-hand side. But in this case, we could use comment tags as a way to bring that sandwich back together, because the comment tags weren't being replaced or zapped by the cookie sanitizer. And we can use these little dashes on the inside of template tags to kind of also consume surrounding white space. And so this is what that looks like. Given that monstrosity, after the first round of templating, it's going to result in something that still looks like a template string, and nothing in that first line is going to get zapped by the cookie sanitizer. Which is to say that sanitization as a security control can be risky. We'd missed this way of doing it for so long. And solving a problem with sanitization relies on your ingenuity as a developer to think of all the edge cases and think of all the ways that your sanitizer might miss something. Or it depends on your pen tester who's doing a retest or being your trusted advisor to have that creative moment. We didn't have this creative moment for a long time to think of another way that we could do this. So sanitization can be tricky to get right. Moving on, 4.0 and 5.0 have come out since. In 4.0, this was a significant change. What had happened is Insomnia had disabled node integration from within the sandbox, which prevents you from entirely using privileged node APIs like require. Big change. And it means that if you could still get code execution through template rendering, you're then kind of trapped in JavaScript land, which is still a fun place to be, but you can't break out through naive shell command execution. There's also a considerable attack surface from within an app like Insomnia. We haven't thoroughly explored it. If you can break out of the sandbox, we'd love to hear how. Hit us up, shoot us an email. And then 5.0 had this change to the file tag, which allowed a user of Insomnia to bless certain paths as being able to be read by the file read operation from within the sandbox. And within the pull request, someone pointed out that this could be vulnerable to ... and then there was some confusion. I think that the person who wrote this PR thought that that might have been a feature request, so that ... could be used within the set of allow lists for the user. But yeah, this bypass works as well. So for the rest of the talk, we'll go full send. We'll bump all the way up to the latest version, which came out a bit more than a week ago, which is 11.6.1. We can still get JavaScript execution through cookies with the template sandwich trick, but we're then stuck there. We can't get out through child process to run an external command. If you want to play along with this, we'd suggest you grab Insomnia from GitHub. You can then open DevTools, render a template that just has the JavaScript command debugger. You'll get a breakpoint, and you can then explore what the inside of that sandbox looks like. From JavaScript, from Electron, even with node isolation or node integration disabled, we can still make arbitrary HTTP requests to stuff on the local network and read the response. Maybe you could build a tunnel so you could kind of squeeze yourself through someone's Insomnia. I'd love to read the pen test report where someone was able to burrow into an internal network through something like this. I think that would be super cool. We can still read local files. As long as someone's added, as long as an Insomnia user's added a path to their allow list for the file read, we can use .. to then burrow back up to where we want to be. But that doesn't really matter anyway. There was a new API added with the disabling of node integration that wasn't protected by that anyway. So we can just head straight for that internal API and read arbitrary files. And remember how Marcio was talking about that environment variables tab, where users of Insomnia could put things they want to reuse across different requests, whether it be API keys or other credentials. And it said that the data in this tab can be used in templating. Well, that means that the data in this tab is exposed to the sandbox for each template render. So you can just yoink and grab those out if you're executing arbitrary JavaScript in that sandbox. In fact, from within the sandbox, you can even see the entry point into the sandbox. The main thread kind of activates that sandbox template renderer through a post message. And from within the sandbox, you can see that on-message handler. You can change the on-message handler. You could replace it with your own function that observes the templating request and then passes it through to the original renderer, or returns arbitrary strings if you wanted to. At this point, you could change that function, hook it, observe all of the template rendering going on across all the request tabs that the user has open, keep tabs on the environment variables that are configured within the environment variables screen, create a repeating set timeout poll thing. The world is your oyster at this point. If you wanted to, you could build an entire JavaScript implant that would live inside Insomnia until the next time it's restarted. You could write your own C2 server. You could do all sorts of things. I don't know why you would do this, but if you did, it might look like this. So we've got an attacker's web server on the left and Insomnia on the right. The user sends a first request to the web server, which sets a couple of cookies. 2 of them. We've got 2 bypasses. May as well use both. We paid for both, use both. Upon the second request, when these cookies get rendered, that hook gets installed. And while that hook's getting installed, we may as well read some files. Maybe we'll grab etc password, loop over each line, look at the home directories, grab some SSH keys, phone those back to the server. And then if the user tabs across to a different request and does any template rendering, it's going to activate that hooked handler. And then that replacement, that hook, can then observe all the things about that other unrelated request. All the body parameters, all the path parameters, all the stuff from the environment. You can grab that and siphon it back off to an attacker's server. Sometime later, 30 seconds, a minute, what have you, there's a background loop that could poll an attacker's server to ask, do you have any JavaScript for me to run? In this case, the server's just saying, hey, what's 7 times 7? Just to kind of pay homage to template injection. But at this point, you could do anything, make local network requests, what have you. So in closing, bug triage is really, really hard, and it's really important. This issue was reported publicly on the GitHub for Insomnia in 2020. It seems to have been disregarded, maybe because the only paths to exploitation seemed kind of high user interaction, because maybe it was deprioritized. And then when Marcio cracked the case of the kind of cookie remote vector, that seems to have kind of spurned some action. But could this have been kind of looked at 5 years ago and thought, we don't know how bad this could possibly be, but it seems like a dangerous, sketchy thing that's going on. Perhaps vendors such as Kong could look at bug reports like this, and without having to be shown the worst that could happen, could look at smells like this and remediate them regardless of the seeming exploitation vectors or the seeming maximum impact. It's tricky though. Mitigating bugs rather than fixing them at the source can be quite brittle. There were multiple rounds of back and forth on this one, various attempts to break proof of concepts, as opposed to reasoning about and considering the root cause of this and fixing it there. And as I said earlier, using things like sanitization depends on your ingenuity as a developer or the ingenuity of your pen tester or your security team to kind of provide you and furnish you with all the different routes and all the different edge cases. Whereas fixing root causes where possible can kind of take care of it all in one swell swoop. So mitigating can be tricky. And design decisions. Insomnia chose nunjucks and then passed things into nunjucks that shouldn't be passed into nunjucks. And this is now really hard to change later on because people are used to the syntax of nunjucks when using Insomnia. But perhaps if a less sophisticated engine was chosen earlier on, something like Mustache, things could have gone differently perhaps. And so early design decisions can be really critical. And lastly, it's 2025, and vol disclosure is still really difficult. We feel like we were kept in the dark somewhat about the plans that were in motion and the fixes that had been delivered. But we think we also could have been more patient in our communication too. When we were preparing this presentation, we looked back on that email chain and saw instances of things we'd said, where with hindsight, we wish we'd elaborated a bit more. Here's our initial advice on recommendations for this. They were quite terse, especially that last line. I don't think it would have been the right thing to write an essay to a developer or to an organization or to a vendor on why we think a certain fix is not suitable. But if we had been a bit more patient in this case, I'd love to know if that could have changed the way that the remediation efforts were approached. I'd love to go back and kind of split the universe and kind of do an A/B test, because we don't want to berate someone we've never met before who frankly probably knows more about JavaScript and Electron than we do. But we want to furnish people with recommendation advice that kind of hits that balance, and I feel like we're still trying to find that balance. Thank you very much.
Heaps of time for questions.
Heaps. Don't know what happened there.
Have we got any questions? Wow. Back.
Yeah.
Awesome talk. Thank you.
Thank you.
Did you do any sort of like Google Docs looking for any exploitation of this in the wild? Like, are there any, YAML files out there that looks like they're doing dodgy stuff?
No. That sounds like a cool exercise, but no, we didn't.
A quick follow-up question. What did you spend the Amazon voucher on?
We're still waiting for it. What would we buy? Maybe some, for me, a sleep mask and sleeping aids. I'd like to get some sleep after this conference, so maybe that.
Any other questions? Yep.
Hi, yeah, good talk. Was it ever pointed out that if a server sets a cookie with braces in it, they don't expect it to be changed on the way back? That's just a bug, right?
Yeah.
Sanitization is one thing, but...
Yeah, we didn't go into that. We thought we were going to be pressed for time, but absolutely. A server, if it wants to set a cookie that contains curly, 7*7, curly, that's its prerogative. It's probably not expecting to get back 49. So I agree. I think this is also a functional bug. Yeah.
Yeah. I think maybe they were just not expecting people to send a template. Yeah. Maybe they're not expecting people to send template through cookies, I guess.
Totally valid. Totally valid.
Yeah.
So you were saying that your usual setup is have Insomnia piped into Burp Suite to log everything for you. If you implemented a full JavaScript C2, is that still going to go through Burp Suite if somebody, if your victim had that set up as well, or is there some way that you could ignore those proxy settings so that they can't even see this?
Great question. Marcio is the Insomnia user. I imagine how do you configure Insomnia to talk to Burp? And then I'll take the second part.
It's just like upstream proxy. You just configure Insomnia to use Burp Suite as a proxy, and that's it. Go from there.
What I would check to know that, it's a great question, is whether doing fetch operations from within the sandbox respect that proxy setting. or if it's only an application level proxy setting that kind of governs how that purple send button works, I'm not sure. That would be what would have to be tested.
Too easy. Thank you.
I know the public reason you called it Sleepless Strings was because the client was Insomnia, but was the real reason actually because Justin got no sleep to do 3 CFPs?
Yeah. Yep. I'm getting home and crashing out. Can't wait.
Awesome. Great talk. Thanks.
Thank you.
Any other questions out there? Yep.
Great talk. Really enjoyed it. I just wanted, one of the last points you made about vulnerability disclosure being so difficult. What do you think, or what kind of advice could you make to software companies to improve that? And I know you also said you had some self-reflection about improving it on your end as well.
Yeah. I think we covered off what we wish we'd done differently, which is to know that level of verbosity to hit. What I wish vendors would do, and this is me personally, I'm yappy. I've worked in organizations alongside developers, and I love working with them on reasoning about security and reasoning about vulnerabilities and reasoning about fixes. I would have loved to have jumped on a 20-minute, half-hour call with a developer who was working on this tranche of bypasses to understand their point of view, express my point of view, and see if we could teach each other things about JavaScript, Electron, and template injection. I would have loved to have chatted with a developer. I don't know who we were speaking with behind that security at the vendor mailbox. I feel like we weren't directly communicating with a developer. And so to vendors, if you've got someone turning up with a vulnerability, it can be scary, exposing developers to unknown quantity outside your organization. I like to think that we try to be kind of friendly, and I would have loved to have talked to a developer directly and see if we can shortcut some of this back and forward, would be my suggestion.
Any more questions? Okay, let's give another big round of applause to Marcio and Justin.